Hello friends, welcome to Shiksharthi. In this session, we shall be discussing quadratic inequalities. So let's start. Now the prerequisite for this session is you should have gone through all the sessions on quadratic equations, functions and expressions before you go ahead with this for a better understanding. Okay, now we are taking a quadratic expression ax square plus bx plus c, and the inequality aspect which is being considered here is less than 0. So for this, let us try and begin like this, which is we are taking a quadratic expression ax square plus bx plus c, making it an equation in terms of equating it to y, which is nothing but the range of this function. And then further on, based on the values of the leading coefficient, the discriminant which is delta, which decides whether this quadratic expression or equation will have real roots, etc. Then we talk about the graphical interpretation of the same. So the first case that we're going to consider here is a being positive. Along with this, delta being positive. Along with this, we have to fix the value of y as less than 0. The second case that we would consider here is a is negative, delta is positive, and y we know in any case is less than 0. Okay, we know a is the leading coefficient which decides the concavity of the graph. The graph in this case has a special name to it, which we call it as a parabola. So now since a is positive, we know that the graph will attain a minima. Okay, this is the graph that we are able to draw. It intersects with the real x-axis. We know that the real x-axis, the y component is 0. So it intersects with the real x-axis at two different points, let's say alpha and beta. And then we talk about which areas of the graph to consider. So we know that below the x-axis is the area wherein we say that y is less than 0. So this is the area of the graph that we are going to consider, because this is the inequality that we are going to discuss here. So let us underline the graph, the area of the graph that we are supposed to consider with an arrow on its extreme ends. Why have we put an arrow? Because the question is only on inequalities and not on equalities. So eventually you would see that this expression gets converted into a times of x minus alpha into x minus beta, and bringing the inequality part here, this being less than 0, which is the area that we are going to consider. The area that has to be considered for the inequality to be imposed on the domain of this function, which is ax square plus bx plus c, is the area below the x-axis, in which x would always lie in between alpha and beta. So this is the answer, or this is the imposition on the domain eventually, which was given rise to the restriction, which was given rise to by the restriction on the range of the function ax square plus bx plus c being less than 0. Okay, in the second case, we know that a is negative. Since we know that a is negative and delta is positive, let us make the graph accordingly. The graph just ensures that it intersects with the real x-axis at two distinct points. And in this case, the distinct points are, let's say, D and E. We know the x-axis is y is equal to 0 and the y-axis is x is equal to 0. Let us talk about the graph, the area of the graph which has to be considered because of the inequality, which is y less than 0 only. So it is only this area that we are going to consider. So let us underline that area which we are supposed to consider with an arrow at its extreme end. I hope it is very obvious now that why are we putting an arrow. Once we have done this, so we understand now this can be written as a times of x minus d into x minus e being less than 0, which means x is less than d or x is greater than e. Now this can this is the solution set that we are looking in for, including which includes variables and constants both. So we finally see that by now what is inequality? Inequality is nothing but the restriction being imposed on the range of this quadratic function, and the solution to this is nothing but the restriction imposed on the domain or the input values to the function. Okay, we can understand this with the help of an example, which is x square minus 3x plus 2 being less than 0. Or we can say we can understand this with the help of an example, which is minus x square plus 3x minus 2 is less than 0. Now we know that a is negative in this case. Is delta positive? Delta is b square minus 4ac. So delta becomes equal to 1 and y is negative. So if we are able to resolve it into its factors, which is just like saying minus x plus 1 and minus x. Okay, let's try and understand it in a different manner. So when we resolve it into its factors, we see that it is 1 minus x into x minus 2, which is less than 0, which can eventually be understood as x is less than 1. Along with this, x is greater than 2. In order to check your answer finally, taking your learning to the next level is take any value which is lesser than 1. For example, you want to take a 0. Substitute the value 0 here in the quadratic expression and see whether the left hand side matches with the right hand side. And the right hand side, consider it as less than 0. So the left hand side is merely the quadratic expression and the right hand side would be the inequality part of it, including the constant, which is less than 0. So when we substitute x is equal to 0 here, we get minus 2 and the right hand side is less than 0, which is correct. Take one value which is greater than 2, which is 3, let's say. How much is minus 3 whole square? Minus 9. Minus 9 plus 9 is 0. Again we get minus 2, which is, so the answer is fairly correct. This is a way to check whether your answer is correct or not.